Let's see. Yep. All right. So we have some things in our roadmap here. We would like to do these things sort of in order. I've tried to, yeah, I don't know. I'm just gonna move this because I don't know when I'm gonna need the transpose function. But yeah, some of these are fairly simple tasks, um, but have to get done anyway. A descriptor heap is a collection of descriptors, which are basically just descriptors of different resources. You use a descriptor heap to bind the different descriptors to the pipeline. Yeah, so it's thing that you normally do. We already created the class in another episode, but it's just empty. Uh, and we need different types of descriptor heaps since different types of resources are described in different ways. So yeah, you have to do it like, uh, or rather, um, you have to create different heaps for that. So right now we've avoided having to implement, or rather not avoided, but we haven't been forced to implement a descriptor heap. But since the depth slash stencil buffer needs to be described on a descriptor heap for the pipeline to be able to find it. Yeah, we need to do that. So there's an interface called Descriptor Heap, which we will implement. And let's see. It will, as per usual, have a default constructor, which allows us to not do anything, and then an explicit constructor. And I think this also takes a device, if I'm not mistaken. Yeah, most of them do. Uh, this is also enough to get us started, and then we do a initialization method for the empty descriptor heap object. Let's see, device. And then of course we do some releasing, and then we do some member variables. So let's implement these three. And as per usual, I would like it arranged inside a namespace bracket. There we go. So let's see, if we call the init method here with our device, we can specify that we create descriptor heap So there's a function we can look up in the documentation. And we have to pass in a descriptor heap description and just where to store the interface. So let's do a description and simply pass that in by reference, and then use our macro to point to the address of this COM pointer, and this returns an H result, and we would not like to run a program where we can't run or create a descriptor heap. So therefore we evaluate the result and throw an exception if it doesn't work. So let's see. These are our values. We always know the node mask is 0 because we do not have multi-GPU support. Yeah, so the descriptor heap types, as you can see, constant buffers, SRVs and URVs are packed together in the same heap type. Then you have samplers, then you have RTVs, then you have depth stencil views, which is what we're focusing on right now, and some num types, which it's just the number of types. Well, alright. Anyway. So we obviously would like to take in a parameter that allows us to create a certain type of heap, and let's just pass that parameter into our method. We would also like to be able to create the size. This is just a basic wrapper, but eventually you'll probably realize why this is needed. And then what it doesn't tell you in the flags is whether it's shader visible or not. So therefore we would instead of passing the flag, we would just ask whether it's supposed to be visible. Yeah. So we copy that, but delete the default argument and copy that. So the number of descriptors is equal to the size. The node mask is 0, and the flags is D3D12 descriptor heap flag visible or flag none. And I just wanted to find that one. So let's ask it, is it visible? If it's visible, we pass in that flag. Otherwise, we pass in whatever flag we found that descriptor heap flags none. There we go. That is basically our descriptor heap. But it's not entirely enough. because we also need to store a variable on how much a pointer to a certain descriptor increases the, or rather how much space a pointer takes. Oh, I don't know why that happened. Anyway, we want to know how to increase the pointer for each element in the descriptor heap, and therefore we have to store the increment value. Let's just do an unsigned integer and initialize it as 0. Let's see, we of course need to pass the type this size and is visible for this to work. Then we, if this doesn't fail, we would like to ask our device to give us our descriptor heap handle increment size. For the type of heap, since it asks what type it is. We can also ask this if this is set. We reset it during release. Let's just create a destructor. Which calls release. There we go. Then we are supposed to have a getter function. Let's say we would like to be able to get a void pointer, or rather maybe a size t. I mean, whenever we let's see, CPU handle is equal to the get CPU descriptor handle for heap start. It's a descriptor handle and then the pointer. Maybe we just want to maybe we just want to return a D3D12 descriptor heap. Maybe D12 D3D descriptor. What was the D3D12 CPU descriptor handle? Let's return one of these. Get CPU disk. Let's do it inline and no, let's not do it inline. Let's do a method for it. So let's handle. Let's set the handle pointer to. Let's delete that for now. To which is our get get CPU handle, return the handle. We would also like a version of this where it const unsigned int index, where we first set our handle to get CPU handle, and then we increase the pointer to our index times increment size. This is a size t, so therefore let's just convert those into size t, and we return the new handle. Maybe we do not want to store it actually. Maybe we do want this to be inline anyway. Yeah, I think so. Let's do inline. And then we can fetch whatever index we have. We might go out of bounds. Let's restore the size. Assert. Do we have assert? Assert macro. Index is lower to than our size. let's see. Yeah, we of course have to release our objects eventually in our renderer. Right now I would like to be able to create a descriptor heap and let's create a depth stencil view descriptor heap. Let's create it before all of this testing. Initialize on our device, and let's do a D3D12 depth stencil view, and we will just create it with one, and we would not like it to be shader visible, since it will be our pipeline that uses it. It doesn't get included in the shaders. So we successfully create one. If we ever ask it, we would like to get the CPU handle for like number 2. I think we should get us an assertion, yeah. Let's see. But this is supposed to be correct, right? Yeah, it works. So now we are able to get the CPU handle. Let's do an inline D3D12 G. I would like for you to help me. IntelliSense, well, it doesn't want to. So let's just do it in here, D3D12, GP, yeah, D3D12, GPU descriptor handle. Let's do an inline, let's do get GPU handle, and just return whatever we can get, if you know what I mean. And get the GPU descriptor for the heap start, and let's do another one of these where we return a GPU descriptor handle and simply call the same thing almost, instead of that we just do it like this, and then we return a GPU handle for the specific index. Yeah. So now we can fetch whatever index we want. And ask for the graphics side of it. Alright. The next thing is our resource. Heap type, initial state. Yeah, I think we will do overloading in terms of our resource to create a depth stencil. Let's see. Mm. Uh, we would like to be able to create a resource which is controlled by our renderer. Depth stencil buffer, but we're supposed to create it in a slightly different way. So yeah, we will do a overloaded version of this initialization method. We will do, instead of this, we will do width, height, since it's basically a buffer that spans our entire render target. I didn't explain what the object actually is. It's a way to store depth or later on stenciling information. So it's basically a texture that mimics the um, the what's it called? It mimics the it mimics uh, sort of mimics a render target, but um, it has other information in regards to that. So it's still a resource. We would just like to initialize it in a different way. Let's see. So we need to pass in the information, which is only dynamic in a few ways. Yeah, I actually think this is it. We could do a standard buffer for a depth slash stencil buffer. So yeah, we will also need a resource description. In general, we would need most of these. We would also need some heap properties. This is going to be the default heap. Let's see. Property unknown. I think this is sufficient, isn't it? Yeah, I think it is. So the width is obviously the width. The height is obviously the height. Let's see. So the dimension for a buffer like this is a texture 2D, which is why we specified the width and the height. It has an alignment of 0. It has depth or array size of 1. We do not have any MIP levels. Actually, I think it might be a bug if we do have MIP levels. Let's see what happens if I change this. Let's see. No, we actually do have one MIP level. But yeah, I guess. Yeah, maybe it's different when it's a continuous block of memory, which isn't organized. So, well, we will do a format like this, since it's what I'm used to doing. Let's see, let's just look it up. What is this format? Okay, 32 bits for depth. So it's a specific floating point format. Perhaps it needs that to compile properly. We will set the let's see, and we will set the flags, resource flags, allow depth stencil. So yeah, I think that is it for our resource description. Then the depth stencil has another descriptor called clear value, which we will initialize as 0. Let's do the same here. The format is the same, DXGI format D1232 float. Let's do clear value. Color. We do not set the color. And the depth is supposed to be, these are just standard values. And the stencil is 0 for now. Then we ask our device to create a committed resource which has the heap properties of the heap prop construct, the heap flags, let's see, usually we call it with the flags of none. We have a resource description. We have an initial state, depth right, and we have a clear value, clear color value. And is that it? Let's see. Clear value. Then we need to store it. ID ppv args. Get the address. This doesn't contain a COM pointer. No, it doesn't. Well, it could actually do that. Yeah, I actually think that we'll do that instead. Now this is wasteful. Let's see. Then we need to get the address of this and add the last parenthesis. And we would like to gxe eval result, since we would not there we go. Now we will have several errors here and there. We would instead have to pass in the address. Oh yeah, that's why I didn't wrap it. Mm. Let's see inside the queue upload. Maybe we just want the ID 3D12 resource pointer. But then we can call the size function. Alright. This will be like that. So it won't have any errors in this function, but let's cast this as a D12 resource pointer. There we go. We still need to do these things. Do we have other errors? We do. Let's see, does everything work? Yeah, everything works. So now it stores the pointer internally on the actual objects instead. Yeah, I think that's better. Perhaps I would like to be able to just cast it as a resource pointer. Let's try out some operator overloading. Now up here. Let's see. Let's see, how do we actually do casting usually? Let's see. Let's see. Oh yeah, it's the other way around. So our operator cast into this is gonna, let's do an inline operator, meaning that we cast the address of, or rather we wrap that into a return the get address of. Yeah, I think that allows us to leave out some of this stuff here. Yeah. Now we can pass it as a reference instead. That looks better, and it doesn't bother me that we do a bit of operator overloading, at least for casting. Yeah, that is somewhat prettier. All right. back to our specific method for the initialization of the depth stencil buffer. Let's create the buffer. Let's do a, what was it, depth stencil buffer initialization, and we want the device here, and we want our width and height, which I think is hard-coded for now. We would also like to name this buffer set name depth stencil buffer. There we go. And we do not get any errors. Great. Then we want to store a view. And as far as I remember, we can create depth stencil view, and we can see we need to get our resource. That is pretty easy. Just get the pointer to it, then a view description. So we have to do a D3D12 depth stencil view description. And let's look into what this contains. So it contains different parameters that we would like to set for our view. We know that the format is set to DXGI format d depth with an integer of rather 32-bit floats. We know that the view dimension is a texture 2D, and let's see. I'm actually unsure. Yeah, so it's for different sub resources if we ever have those. So yeah, we will create it without any flags. As you can see, you were able to specify only depth or only stencil, but we do not want to give it any flags. Then we pass in the descriptor, DSV description, and we want to get the CPU descriptor handle. So remember when we created our descriptor heap up here? Wasn't it up here? Yeah, it was up here. We created one with an index of, or rather a size of 1. So we can actually move this a bit, so it doesn't have to be inside the vertex buffer, index buffer shenanigans. Let's just move it up here, and we know we want to store our view into the heap here. So let's get the or rather get the CPU handle for our first index, and this should actually create a depth stencil view. Well, did I move something? Let's see. Okay, we have an error which resulted in an removed. Okay, so the dimensions of the view are not valid. MIP slice value. Let's see. At least one of the MIP slice. Let's see. What is the default value? Let's see. Maybe I need to initialize it as 0. Let's try that. Oh well, that was it. I didn't initialize it at 0. Great. Now let's check out what we've achieved in NVIDIA Insight. Let's see. Let's compile. I'll just be making sure that our shaders are updated. They probably are, but better safe than sorry. And then inside our inside application, let's see, we have now descriptor heaps. We have for the render target views. Usually those get created during the swap chain creation. And then we have a descriptor of a depth stencil view, which points to our resource, the depth stencil buffer. Yeah. I think we need to bind it to our pipeline during frame generation. But yeah, as you can see, both the resource gets created and the view to it. Yeah, it only has the size of 1, which is entirely correct. I think it creates these manually during the swap chain execution. Yeah, so these are several frames, past references to frames. And since we have a constant buffer but not a descriptor heap where we can look it up, yeah, we get an redirected CPU handle in Insight. Yeah, but it doesn't really matter much. Yeah, so last thing I think is to use the depth stencil during frame generation. Let's just, if I remember correctly. Yeah, so we have to find our begin frame, and we would like a CPU descriptor handle to our depth stencil view, and we ask our DSV heap to get us the CPU handle of our first depth stencil view. Then we would like to tell the graphics command list to use the depth stencil view. So we clear it. We pass in the handle we just created. We pass in a flag to clear the depth. We would like to have a depth of 1. We do not use a stencil or any rects, and we do not have any rects to point to. There we go. And we do not get any error messages, even though this runs every frame. This basically means that we actually do have a sense of depth in our normalized screen space, meaning that it will hide objects whenever they are behind something else. And not render it to the screen. It doesn't mean that the vertices aren't parsed or generated. Actually, it just overwrites through the depth buffer, which pixel is supposed to go on top. So it still draws every pixel for every object behind the object that is closest to the camera, but yeah, if you want to avoid that, you have to do so-called frustum. No, you can't really avoid it, but at least you can avoid it in terms of objects that are outside the camera. But that's for frustum calling, and yeah, we're not doing any calling anytime soon. So yeah, if I remember it, I'll show the effect of having a depth buffer applied to each frame. It will be way easier to show the effect of these different things, at least, or rather, I can't show you the effect of not clearing the back buffer because we're supposed to do that, and we're also supposed to set a render target, but I could show you the effect of the depth buffer. Yes, all right. So far, so good. I think for the sake of YouTube, I will disable the stream on YouTube and segment the video, since doing a descriptor heap and a depth stencil buffer and its view is a pretty fine video. So I'll just do that. Hopefully someone found this helpful, informative, or in other ways finds a way of appreciating it. If you do, feel free to comment, like, and subscribe, or even follow